Hey guys, how you doing? This is Mr. Myasis, and I'm back with another video here for Algebra 2, talking about the fundamental counting principle and just some basic counting techniques. And we're also going to talk about what an independent and a dependent event are. So let's first talk about the counting principle. Basically, it means if you have two events, we multiply the number of ways one event can occur times the number of ways the other event can occur, and we get the total number of ways both events can occur. We kind of did that in class a little bit intuitively, and this time is we're just going to use it. We're going to give it a name. So let's take a look at some examples. So you know, if I have a coin being tossed and a die being rolled, then I have two things going on, right? These are two events. This is an event. This is an event. And to know how many ways I can toss a coin and roll a die, I would just multiply the number of ways here, 2, by the number of total ways here, 6, and I get the total number of die rolls. Now I can list all the outcomes. I can have heads, tails, heads, heads, you know, I can list them all out. Excuse me, I can have a heads and a 1 on a die, a heads and a 2, and a heads and a 3, tails and 1. If I list them all out, I'm going to get the same thing. So it's a lot easier to use the counting principle than it is to write all of the outcomes out. But we still need to know what the number of them are. So let's take a look at an example. Stella has to pick a shirt and a skirt to wear on her date. Ooh, a date. And she looks a little young for a date. She has 3 shirts, blue, purple, and black. And she has 2 skirts, denim and black. So we got 2 events. We have the event, she picks out a shirt, and the event, she picks out a skirt. All right? So if I was going to list all these outcomes, you know, I'd have a blue shirt with a denim skirt, and a blue shirt with a black, and purple, denim, purple, black, and so forth. We write them all out, right? Black, denim, black, black. Now, if we just want to use the fundamental counting principle, we see how many possibilities are there for shirts. Okay, what I like to do is I like to use spaces. All right, space, space. This space is for shirts. This space is for skirts. How many ways can she pick out a shirt? 3 times how many ways can she pick out a skirt? 2, denim and black. We multiply those guys together and we get 6. Bam! That's all there is to it, all right? I like using spaces. It seems to be intuitive. Let's take a look at another one. Has many outfits can Stella make if she definitely wants to wear a purple shirt? Well, if she definitely wants a purple shirt, it takes out the fact that she has a blue and a black one. So how many outcomes are there now, or how many possibilities are there now? There's 1 for shirt, and now for skirt, there are 2, still 2. 1 times 2 is 2. Now you could have figured that out without multiplying, but I'm using the counting principle. All right, let's take a look at another one. A menu offers a choice of white, wheat, or onion bread. Okay, so bread would be my first. I'm going to write this here in my space. Bread would be one of my first events, and with a side of chips or salad. So here's my side. Oops. Okay, so I have chips or salad. How many different lunches of bread, meat, and side are there? Oh, I forgot the meat. So let's put meat here. Meat is turkey, ham, pastrami. So I've got 3 events. All right, I can list all the possible outcomes, which I will do in just a second. All right, so there's all the possible outcomes. I can have my event bread, my event meat, my event side. How many possible breads do I have? 3. How many meats do I have? 3. How many sides do I have? 2. 3 times 3 times 2 is 12. Should match up with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I do this wrong? Sorry, 18. You're probably going, Mr. Myasis, 3 times 3 times 2 is not 12, it's 18. So I got them all there. All right. So if we were picking these 2 events, if the 2 events are independent, it means that one event doesn't affect the other one. So if we go back here, example here, me choosing white bread does not affect me choosing, doesn't matter what I choose for my meat. It's separate than my bread. Okay, so the event meat is independent of the event bread, because it doesn't matter what kind of bread I choose, depending for my meat. Now, if they're dependent events, it means it does affect the second event. Is affected by the first event. Meaning, like, a good example is if I take a deck of cards and I take one card out of the deck. Now I don't have 52 cards in the deck anymore. I only have 51 cards in the deck. So what I pull in the next, what I draw on the next card is going to be dependent upon what I draw on the first card. Okay. So my outcome is going to be dependent if it changes, if it depends on what happens in the previous trial. So let's take a look at identifying some. How many 2-digit codes are possible in each situation? So what I'm going to do is I'm going to write down 2 digits, right? My event, digit 1, digit 2. So for A, any 2 digits. So I could pick any 2 digits. In 2 digits, we got 0 to 9. Those are the digits, right? So that's 10 possible digits for first one. And then if it could be any 2, I can repeat, right? I could pick the same thing. So it's also 10 possible digits for the second one. Now, since it didn't matter what I picked here, right? If I picked a 1 here, that doesn't make any difference from what I'm going to pick on this one. These 2 events are independent. Aha! So what's the answer here? 10 times 10 is 100. 100 ways. What if I change this to the first digit is even? So let's look at this. Digit 1, digit 2. How many ways are there to pick digit 1? It has to be even. 2, 4, 6, 8. 2, 4, 6, 8. There are only 4, not 5, guys. There are 4 of them. Okay? Now, the second digit can be anything I want it to be. There are 10 digits, right? 0, are we going to count 0 as even? Let's go ahead and count 0 as... 0 is not really... Well, let's count 0 as an even. So let's count 0 as an even. So that would be 5. So we'd have 50 ways. And these events are independent. They're independent because it didn't matter what this was for when I picked this one out. Well, what happens if no digit is repeated? So if when I pick 0 to 9, digit 1, digit 2, I have 10 possibilities here. But when I pick 0 out, I no longer have a 0. I only have 9 that I can pick out because the 0 is gone. So this one right here depends upon what I pick here, right? Because I took one out. These are dependent. Dependent, which I get 90 ways. Right? Does that? Hopefully that makes a bit of sense to you. That if this one here, okay, if this one changes because of what I did here, then it's dependent. This doesn't matter what I did in the beginning, it's independent. These 2 events are independent. Lance's math quiz is 8 true or false questions. How many different choices for giving answers to the 8 questions are possible? I think what this question is really asking is, if I have 8 questions, 1, 2, 3, 4, 5, 7, 8, I could pick true here, I could pick false, true, true, true. I have 2 possibilities for each one, right? So I have 2 events. I have 2 events. I have question, so I have answer, and I have question. I believe this would be the way I think about it. How many different choices for giving answers to 8 questions are possible? The 2 events, answer and question, it doesn't matter what I answered in question 1, right? I could still answer true or false in question 2. So these are independent. How many possible answers are there? Well, there's 8 answers with, I'm sorry, there's 2 answers I could give, right? There's true or false. Whoa, that's not the one I wanted. It's a little highlighter there. And there are 8 possible questions. So I have a total of 16 different ways that I can answer this, right? For college application, Gwen must select one of 5 topics. Okay, so we've got what's the first event? Topic, right? And how many ways can she select the topics? 5. 5 ways. She can write a short on which to write a short essay. She must also select a different topic from the list for a longer essay. So this is topic for short. I'll put short. And this is topic for long essay. How many different topics for the long essay? She must also select a different topic from the list for a longer essay. So listen, guys, she cannot pick the same one. If she picks this topic, one topic for the short essay, she's got to pick a different topic, different one, for the second essay, which means now she only has 4 possibilities. So you get 20. So since this one was dependent on this one, these are dependent events. See, it almost makes sense to figure out the counting idea before you figure out whether they're dependent or independent. So last one today. Amy needs to put 4 different bobbleheads on the shelf. Everybody loves bobbleheads. If you can see me right now, you'll be seeing that my head is bobbling. How many different ways can she place the bobbleheads on the shelf? Okay, so she has 4 different bobbleheads. How many different ways can she place the bobbleheads on the shelf? So we're going to say this is dependent, right? She's got bobblehead 1, bobblehead 2, bobblehead 3, bobblehead 4. These are the spaces that she's putting on the shelf. You can imagine here's the shelf. Here's space 1, space 2, space 3, space 4. If I put, I have 4 different bobbleheads for space 1. But if I put one down here, I only have 3 others to put there. And then if I put one down there, I only have one less. Okay? This turns out, if you don't remember what this is, 4 times 3. When I have a number that starts and goes all the way to 1 and I'm multiplying that, I can write it like this with a 4 and an exclamation point. This is called a factorial. Sometimes I'll just say it's 4! Like I'm golfing. Get it? Because I got excited. Okay, anyway. 4 factorial, but we multiply this out. 4 times 3 times 2 is 24. Okay? All right, that's all I have for you today. We'll talk to you soon. Later.